But in today's lesson, we will use the, you'll see, painstakingly technical way of using algebra and limits to come up with the derivative function, not just the derivative at the point. So what we're doing is we're getting a whole new function where we could use the derivative function to find the derivative at any particular point along the original curve, around the original function. So let's just get started and you'll see what I mean. So the derivative as a function of x, what we're going to do is we're going to use the difference quotient, and notice instead of evaluating x at a particular value, a numerical value, we're going to do this limit as h goes to 0. So h is still a number that we're making get very close to 0, as close as we want it, almost 0. Actually, we're going to get it to the place where we can plug in 0. But right now in this function, we can't. X is going to stay there as a variable within this function, and so we'll have a derivative that is actually a function that has an x in there. So we're going to use algebra to simplify the expression, and where we can actually let, right here, we'll let h, we'll let h actually go to 0. We'll just plug in 0. We can't do it right now, obviously you can see, because there's an h in the denominator, but we're going to find the way for it all to work out just fine. So let's take an example. We're going to take the example of finding the derivative function f prime of x for the function f of x equals x squared. So there are, remembering from that difference quotient, there's two parts to the numerator. There's f of x plus h, and then there's just f of x. So we'll find them separately. And this is a similar approach that our textbook takes. So I'm going to click through this so we'll have it sort of clear in this sort of simple case. Then we're going to see how it applies to a more complicated function. Okay. So when we plug x plus h into the function x squared, notice we get x plus h squared. To square it, you could write it twice and then we FOIL it out, right? X times x is x squared. X times h is hx, but we get two of them, right? H plus x, h plus x. We get two of them. And then the last FOILing out is h times h, which is h squared. So we're going to have this in the numerator as one part. We're going to plug in f of x, which means we're plugging x into the function. And I might have gone overboard here, but we plug in x to the function x squared, so it look like that. So it's just x squared. But we're going to use this difference quotient, so f of x plus h is the first one. The green one goes there, minus the red part all over h. And that gives us this function. Now we still can't just let h go to 0. Sorry about this. Let's click through. I think it's too late in the day, too hot for my computer to keep moving. So sorry for that little blip there. I might be able to edit it out. We'll see. What I want to be able to do here is let's use blue as a new color, third color. So what we're going to see is we use algebra. We've got a negative x squared and a positive x squared. So combining like terms, that becomes 0. So those are gone. They cancel out. And what's left is 2hx plus h squared all over h. And there's this limit part here. We could write that in there as h goes to 0, remembering that part. In the numerator, we're able to factor out an h. So we have h times 2x plus h. Still one h left, so we factored that out, all over h. And again, we have our little limit as h goes to 0. The h's now, h divided by h is 1, so they're canceled out. And so we have this limit as h goes to 0 of 2x plus h. So now from our previous sections, we know we have a closed form function. We can go ahead and evaluate this at h equals 0, plugging in 0 for h. And so our final answer is going to be that the derivative function f of x is equal to 2x. So we started with f of x is equal to x squared. And you'll see, does this 2 have something to do with this exponent? And it does. We're going to see this when we get to 11.1. Really, this exponent comes down, multiplies in front, and then we're going to subtract 1 from the exponent. And so this is x to the first power. So you're going to see we've got sort of an easier way to do it. But for this lesson, we're going to do the algebraic way so that we make this connection of understanding what a limit is, that we're taking the two, that we started with 2 points, we bring them in and make them to 1, and then at the limit of the distance between these 2 points being 0, so at 1 point, we get a derivative, and we can actually get a derivative function. Okay, so the rest of this, that's really the lesson today. The most difficult part you will probably face, if you're like myself and most students, is this part here, f of x plus h. So it's a composition of functions that we've done elsewhere. So this gets plugged in for x everywhere. This part's pretty easy because you're just taking the function that we start with and you're putting a negative on it, you're subtracting it from it. And what you'll see as a sort of a natural thing that happens here is much of the 2 functions will cancel out. Actually, everything from f of x will cancel out with everything from f of x plus h. What's left behind will be able to factor out an h, cancel out the h, and that's basically what our derivative will be. Okay, so this one's not too bad, but let's take a look at the next. Okay, so let's clear this PowerPoint. Let's move it back to a pointer, and let's take a look here. Now, this one I'm allowing the textbook to do much of the work for us. Okay, so they took the function and we used this one in, I think, 10.5 as an example. It was a ball being thrown up in the air. So it's a function s of t. S is the height in the air. T is the time the ball, since the ball was thrown. And we've got this equation here. So if we follow through what we were doing with the last one, that would be the red part. That's the part we're going to subtract that will be plugged into this part of the function. The s of t plus h, notice I'm at t, but I'm going to add h to it, and we're going to let h go to 0. So there's 2 values for t, or 2 t spots, 2 input spots. So I have to put t plus h into both. And then one of them is squared, so I have to FOIL out and then distribute. And one of them I just have to distribute. And then I have to combine like terms, and I get this long expression. And that is what's going to go in the first part of the difference quotient. Again, you could do it in either order. I started with this. I usually will start with what's more difficult, and then the function itself just goes behind there. Okay, so let's see if we can write this out. So we're going to get the limit as h goes to 0, and you'll do this a few times, but remember there's it'll get easier. Let's just put it that way. Okay, so we put in the green function, so that's 100t plus 100h minus 16t squared minus 32th, and finally minus 16h squared. So that's the s of t plus h. Then we plug in, we subtract off, and again, one of the important things to do is remember when we're subtracting, we put a parentheses that this negative has to distribute. That is something that oftentimes gets left off by yours truly as well. Okay, because you get in a hurry and just want to write it down and you forget to distribute it through. But once you get enough experience, you realize that things have to cancel out. And when you saw that if you don't get this t squared part to cancel out, you'll know to look back and pick that part up. Okay. So that's the idea of what's happening. And then again, we just have an h in the bottom. So this is going to distribute through, so we will have a negative on the 100 and a positive on the 16 squared, right? So we've taken care of that negative. Negative 100t, a positive 100t, those combine to become 0. And here it is, a negative 16t squared and a positive 16t squared. Those combine to be 0. So notice the original function ends up canceling out with the parts in the front, the part where we went to t plus h. Everything that's left has an h in it, so we're going to be able to factor out an h. So this becomes, again, limit as h goes to 0, and we'll just write it, it'll be 100h minus 32th minus 16h squared all over h. We will factor out an h so that we can cancel with this h. So this is kind of like a second part here. And again, I took this right out of the textbook, so they worked this out as well. I just wanted to sort of start and show how it can be a little bit more complicated. We're going to do one that's a little more complicated from scratch as well. Okay, so just take some practice. Factor out the h. So then we've got the limit as h goes to 0, h times 100 minus 32, the h came out, so that's 32t, minus 16h, because only one h came out, right? We've got an h down here. H divided by h is 1, so that happens. We're left with this statement inside, and it's a closed form function. We can evaluate it at 0, and when we put in 0 for h, this minus 16 times 0 is 0, so this last part just becomes 0. And what is left is simply 100 minus 32t. And that is the derivative function, s prime of t. That's our derivative function. And notice that what we started with was 100t minus 16t squared. So you would be right in seeing that what's happening here, and we'll do this in our next section, to actually take this derivative. The 2 comes down times a 16. 2 times 16 is 32. Subtract 1 from the exponent. Down here, 2 minus 1 is 1. So that this is really t to the 1 power. Same thing happens here. This is t to the 1 power. 1 times 100 is 100. Subtract 1 from the exponent, that's t to the 0. Anything to the 0 power is 1. Not 0, it's 1. So that's 100 times 1, which is 100. Okay, so again, you can look at this example as they do it. What we're working on is building up some algebra skills. And again, the hardest part we're generally going to face is going here. Generally, if you're not getting the correct answers, your errors probably are coming from this part. Okay. Any questions? Of course, got to try them out. But we'll keep moving in this video. Then again, at the end, I will summarize the homework and sort of its approach. So let's take one from scratch and just see how we do. Okay, so we're just given one like this. Going to go ahead and break it down to the 2 parts. So remember, we're going to use the difference quotient. So we're going to have a part that is f of x plus h, and we're going to have a f of x. F of x is the easiest part because they already gave it to us, right? Actually, let's make that red just to be consistent. So this part, we're just going to, it's the red. It's the function itself. And then we'll come back here. We'll make the other part green. So this part actually is not too bad. We're just plugging x plus h in for the x. So that just gives us 1 over x plus h. So not too bad yet. Okay, that's our pieces. We're going to put it into our difference formula, difference equation, the limit thing. Okay, and what you should do is you should be writing these down multiple times each time you go through it, because the more times you write it down, the more you will not only remember it in your mind, but you get your muscle memory. Your hand starts remembering them. You learn by doing is really what's happening. So that's all this writing again and again will emphasize it too. So what do we have? It's the limit as h goes to 0. What is it? It's f of x plus h minus f of x all over h. And remember, that's really just a slope function. 2 y values being subtracted in the top, 2 x values in the bottom, but the x value of x plus h minus x, the x is canceled out, and that's what we're left. So this is just a slope function, and what we're doing is we're letting h, which is the distance between the 2 points, go to 0. So it brings the 2 points together. We get the slope at a point. Okay, so what we do is we're going to go ahead and plug in the green part. So we get limit of h as it goes to 0. And in the numerator, we get 1 over x plus h. We get the h in the bottom, and we're going to subtract f of x. And that's the part I'll make red so that you'll see. Now, it would be nice if we could just take 1 over x and we could subtract off this 1 over x, or if we could somehow separate this into 1 over x plus 1 over h, but that's not how fractions work. So what are we going to do? We're going to get a common denominator. The common denominator will be x times x plus h. So the first one we have to multiply by x over x, top and bottom by x. The second one, we multiply x plus h, x plus h. Okay. And And again, it gets messy. You can always kind of do things. So what this gives us in the first part, it gives us x over x times x plus h. I suppose you could distribute that out, but if I remember right, I think it ends up canceling out anyway. Minus x plus h over x times x plus h. So remember, that's all in the numerator. Still have this denominator down here. And we'll do the limit as h goes to 0. Looks like I might even want a whole nother screen. They have a common denominator. So I'm going to do an invert here. You can see why, and as you can see, maybe my camera's right in front of my view too, but I try to make it look like I'm just here working some problems, but we have equipment going on. So this is going to be x minus x plus h. Now this subtraction here is going to distribute to both parts. So what the numerator becomes, let's go ahead and write it out, x minus h. So I distribute it in that sense. And then we have x over x plus h. And we might need to do something with that, divided by h. And this is all limit, right? We try to let h go to 0. Well, we can't let h go to 0 yet. So what I'm going to do is I'm going to rewrite this fraction times 1 over h, because that would be the reciprocal of h is 1 over h. When you're dividing by h, you're multiplying by the reciprocal. So hopefully that makes sense. I think there's one like this. Again, we're going to get some rules that make this a little easier to deal with. X minus x is 0. So in the numerator, I have a minus h. In the denominator, I have an x times x plus h. And I'm going to multiply that by 1 over h. And that's the effect of bringing this h from the denominator. Remember, it would be divided by h over 1. So you turn it to multiplying 1 over h. Okay, so that's why we have this. Cool thing that happens, h divided by h, is 1. Okay, and now what do we have? We have the limit as h goes to 0 of -1, right? The negative's left in the front, -1 over x times x plus h. Now you could have distributed through, but notice we can now let h be 0, because when h is 0, this just becomes x plus 0, which is x times x. So as we evaluate this as h goes to 0, this becomes -1 over x squared. Beautiful. That's exactly what it is. Now what we're going to see and how we're going to do this is, what is f of x? You could look at it as 1 over x, or if you use negative exponents, it's x to the 1 over x to the first power, move it up, and that becomes x to the -1. And now let's see what happens when we've been applying our rules. I'm just getting you to see. So take this exponent, move it down in front. You got a -1 x, subtract 1 from that exponent. -1 minus 1 is -2. Look at, we ended up with -1, move it back downstairs over x squared. So I'm just trying to get this as a connecting fiber between what we've been doing with limits to mathematically and painstakingly show that this works based on, finding the slope of 2 points, that we're able to do this magic of moving the 2 points together, and at their limit, we end up with a derivative. What we're going to soon be doing is just taking the derivative like over here. So we're going to go, this is our work right here, or this is our work with limits. Which one would you rather do? Well, the work with the limits maybe helps us understand it, maybe helps us believe it and see it. But I'll tell you what, once we get to the rules and we start seeing that they work and accept them and go with it, we can get a lot more done more quickly. Okay, so here's our homework for 10.6, at least a static version of it that I've printed as a PDF file. I'm not sure if I have these in there. I can put them in Canvas if you'd like. Just let me know. So this first one is kind of like what we did in the example. There's two places to put an x. We're going to, again, need to get f of x plus h in here. So there'll be an x plus h here and x plus h there. Expand it out and use the difference quotient. Here's one very similar to what we did, except we've got a negative on it. So, and again, you may have a different value than just a -1, but go ahead and go through. You should be able to do well. What you're going to see is whatever number this is, it's a constant, and it will just sort of carry through the program, the problem. F of x plus b, our f of x equals mx plus b, that's a linear function. This will work very similarly. You'll see the b's will cancel out. Just use the m and b as constants. Keep them in there as if they were numbers. Treat them as if they were numbers. And they are not variables. They are just numbers. Okay. If it's helpful, you could just plug in numbers, see how that works. Put in 2 and 3 if you want. And then replace your final answer. Wherever you see a 2, put an M, and wherever you see a 3, put a B if there's anything such thing left. Okay, so that should be pretty good. Compute the indicated derivative. Now this is a derivative at a point. Partly what they want you to do is go ahead and find the actual function and then plug in 2 of the derivative function. That's, to me, a little bit extra work. So you can use any of the methods. We've really been working problems like this, either using limits. And I also showed with the calculator that you can put this into y1, put the function into y1, and the calculator will calculate the derivative at a point. So we'll talk about that a little bit more in class. I'll show you some more examples, and we'll see if I can't make some calculator videos specifically over the weekend if they're needed. I try to implement some in there. Same thing can happen here. Okay, find the equation of a tangent line, except this one, what you need to do is you need to find the slope. What's the slope of the tangent line at when we're at 1, x equals 1, so we'll plug that in. Again, you could use that with the technology. And while we're here, why don't I just show that? I'll show it with the TI calculator. Let's see, where's my TI calculator? Here it is. And again, there's a 90-day free trial on these. Let it pop up. Nice thing with the TI, it will actually go all the way and find not just the slope of the tangent line, but the equation of the tangent line. So I'm going to clear it off, and then I'm going to move it over here. And remember, there's our derivative, our limit for our derivative. If we wanted to, you could leave that in there if you want, or I've just got it unselected, so it's not going to do anything with it. So what I would put in here is x squared minus 7 for this particular problem. X squared, get out of the exponent, minus 7. Okay, so there's a couple ways I can do this. I can go to the graph, and we are looking for the derivative at a equals 1. So what I can do is there's a calc function here. I go second calc, and I can get my derivative, which is number 6. And then I just plug in 1. I want the place I want it at, 1. It tells me that the derivative, dy dx, which is another form, is actually 2. So the slope of the tangent line when x is equal to 1 is 2. The other thing I need here, if I want to find the equation of the tangent line, and I'll do it both ways, is I need to find the function value, and it gives me that. So it says when x is 1, the function value is -6. So I really have everything that I need to find the equation of the tangent line, and I'm going to go ahead and do that here. So what we found out is we found that the derivative, the slope of the tangent line, and I'll write that as m, is equal to 2. We also found that that point it goes through there, so the tangent line is going to go up like this, so it should have a positive slope. It does. What you're going to see is this is a point on the tangent line as well as a point on the function, 1, 6. And so we can find the tangent line by using the point slope formula, y minus y1, this is from algebra, equals the slope times x minus x1. And so then we plug in our values. So our slope is 2, put that there. Our x1 is 1, and our y1 is 6, actually -6. So we get minus a -6, which is a +6. Okay, so we distribute on this side, we get 2x minus 1, we get y plus 6, and to finish solving this, we just subtract 6 from both sides, and we get that the equation of our tangent line is going to be y equals 2x minus 7. Now what I want to show you is that it was just like, but 2 or 3 clicks of the ruby red slippers takes us home. There is actually a function here which is on the draw. Again, I've showed you, so we go second draw. Similar, see, it hasn't done it yet. Oops, I'm in the wrong place. Okay, sorry about that. Let's see if I can take it out. Maybe I can't. So we go second. That's right. I have to go to this guy. Second draw. It's right above program. And I can choose to actually draw the tangent line, which is number 5. This is so cool. I just love this part. We plug, where do we want the tangent line? We want it at x equals 1. I just tell it x equals 1. I hit enter. Watch this. I get to see the tangent line. I get to see that I'm at x equals 1. And I even get the equation of the tangent line. Oh, I did something wrong. Oh, now I'm embarrassed. But we're going to leave this in the video because what did I do wrong? You probably were screaming at me when I distribute this 2. It's not 2x minus 1, but go back to the blue. It's 2x minus 2. Remember, this has to distribute. Told you, I will make mistakes. So it's 2x minus 2. And then we take -2 minus 6. So it's not -7, it's -8. And that's why I really do encourage using the technology, but I also encourage doing it by hand because it gives you information about the way you study, the way you learn, the types of mistakes you're going to make. I know the type